Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department from Ajay Kumar Garg Engineering College, Ghaziabad. Today we are going to discuss the topic Memory Connection to CPU and Memory Address Map. This particular topic is taken from the subject Computer Organization and Architecture. Now, in this particular discussion, we are going to discuss some topics about the memory, RAM, and ROM chip, how RAM and ROM chip is connected with the processor, and what are the range of addresses when the particular data or information is going to be stored. And we also discuss the numerical example of the memory connection to CPU, and after that we are using that memory access methods. As we know, what is memory? Memory is a space where all the data and information are stored. In the computer system, the memory is wherever the data has been stored. There is, maybe possible there is a primary memory or a secondary memory. So, you can say memory is like a human brain. In the human mind, there is a human brain where all the data has been stored, and in the particular computer system, there is a memory or a primary memory or a secondary memory. These are the characteristics of the main memory. The main memory is nothing but it is a primary memory, and main memory is why it is called main memory, just because this particular main memory is directly connected to the processor or a CPU. That's why it is called as a main memory. Main memory is a combination of the RAM and ROM, that is random access memory and read-only memory. Now, these are the some characteristics of the main memory. Main memory is a volatile memory, and it is the main part of the memory. There is a primary memory. There are RAM and ROM is there. Random access memory and read-only memory. Why random access memory is called as a RAM? Because there is a accessing method. Any particular data or information we can store in this particular RAM randomly and accessed randomly. That's why it is called as a random access memory. And read-only memory, in the read-only memory, we cannot update whatever the data or information are stored in that particular memory, but we can read that particular data. We cannot update. So, here there is a RAM and ROM chips are the concept. There is a RAM chip and ROM chip that are connected directly to the CPU. As we discussed that the main memory is directly connected to the CPU, and the main memory is combination of the RAM and ROM chips. So, any particular memory, whatever, the auxiliary memory or a virtual memory or a main memory, we can consider these particular memory as the notation as a 2 to the power n into m, where n is the n bit address bus and m is the m bit data bus. N bit address bus means there is a n bit, suppose that n bit address bus is there, and m bit data bus can be a unidirectional or a bidirectional. Here is the RAM chip and ROM chip is there. In the RAM chip, because it is a random access memory and there is we can read and write both. That's why there is a pin of read and write there. Read operation in which that whatever particular data or information we want to read from the memory, and write if we want to update or write that particular data or information in the memory, then we can also update in the particular RAM. So, there are a pin read and write, but in the ROM read-only memory, there is only the particular, we can only the read operation. We cannot update whatever the operation is or whatever the particular data information is stored in the ROM. Now, there are the two terms, there is a CS1 and CS2, chip select 1 and chip select 2. Actually, the chip select 1 signifies that in particular when we are going to store the data, there is a maybe possible because the primary memory is a combination of RAM and ROM. So, data and information can be stored in the RAM or ROM. Chip select 1 decide that particular data or information is stored in the RAM or a ROM. that is for the chip select 1. And now there is a, you can see there is a AD7 is there, that is a address 7 line. How we can calculate this? That is a 7-bit address is there. 120, here the RAM capacity or the size of the RAM is written over here, that is a 128 cross 8. This 128 cross 8 can be written in the form of 2 to the power n into m. This 2 to the power n into m, so we can write it here as a 2 to the power 7 into 8. That's why this 7 bit is, and next is the address bit is 7, and there is a 8-bit data bus. Here we can see there is a bidirectional values. In the RAM there is a data bus, and data bus is a bidirectional data bus, means when the data is transferring from memory to data, there is a memory to data, there is a, and vice versa is also applicable, means memory to CPU we can transfer the data, and the CPU to memory we can also transferring the that particular data. In the ROM there is a unidirectional data bus. In the unidirectional data bus means it's particular, there is a only the memory is transferring the data to the CPU, but not the vice versa is applicable. So there is a AD7 is the 2 to the power 9, and there is a 512 cross 8. This 512 cross 8 we can write again as in what? In this particular ROM chip we can also write it over here, that is a 2 to the power n into m, in the sense this particular significance can be applicable in any type of memory, means may be possible virtual memory. Here we are reading as a RAM and ROM chip, or we are using virtual memory or auxiliary memory. We signify this 2 to the power n into m, so that we can calculate how many address bits are required and how many data bits are required. Now here, because the ROM chip size, this particular single ROM chip capacity is 512 cross 8, and it can be written as 2 to the power 9 into 8, so that we can say there is a 9-bit address bus and the 8-bit data bus is there. Here no read lines is there. Now these are the significance of the RAM and ROM chip. In the RAM and ROM chip, actually because the data bus is the bidirectional data bus is used, so this bidirectional data bus can be constructed by the 3-state buffer, in which there is a logical 0, logical 1, and there is a high impedance state. So logical 1 and logical 0 is the simple logic 0 and 1, and the high impedance state is the open state, means all the particular data or information is in the treated as an open circuit. This is the high impedance, that is treated as a open circuit. There is a no logical significance over there. So here there is a some configuration about the RAM chip. We can also read that there is a CS1 and CS2. The chip select 1 and chip select 2 is what it means, that the if the chip select 1 is enabled or equal to 1, it means that particular data or information is stored maybe in the RAM. If the CS1 is 0, that means it will be stored in the ROM. Now suppose there is a total memory capacity of the system is 1024 cross 8. It means what? The total size of the primary memory is 1024 cross 8. So that the primary memory is designed with the help of what? RAM and ROM, because it is a combination of RAM and ROM as a total memory. So the total capacity can be divided into the two parts. So we can say if the total size is whatever 1024 cross 8, then the total size of RAM can be used as a 512 cross 8, that is the half of the total memory capacity, and the total size of the ROM capacity is the 512 cross 8. So after that we can calculate the number of RAM chips required. What are the number of RAM chips? That is the total capacity of the RAM and the single RAM capacity. Here we can use that what is the size of the total memory is divided into the two parts, that is a RAM and ROM, and how many RAM chips are required to design that particular primary memory is, there is a formula for total RAM chips required. That is the total capacity of RAM and the single RAM capacity is there. And the number of ROM chips are what? Total capacity of ROM and the single ROM capacity. So, if in this particular example, because the total RAM chip, the total size of the memory is what? 1024 cross 8, and it is divided into the half part, that is 512 cross 8 and 512 cross 8. So, we can say the total number of RAM chips required to design that particular complete memory is called as a 512 cross 8, and the single chip capacity is what? In the RAM, that is 128 cross 8. That's why there is a 4 RAM chips required. Again, there is a total number of ROM chips required. Total size, total capacity of the ROM is what? It is divided 1024 cross 8 divided by 2, that is 512 cross 8, and the single ROM capacity is 512 cross 8. That's why here 1 ROM chip required. Now, there is some terms are there how the memory connection to the CPU and the memory address map is there. Actually the interconnection between the memory and processor is then establish the size of the memory with the RAM and ROM, means how that particular data or information is transferred to the CPU or CPU to memory. And there is one more term we have to know, that is for the same size of chip, means RAM chip or a ROM chip for the same size of chip. It is possible to have a more bits of ROM than of the RAM. Why? Because the RAM having the reading and writing capability, but the ROM is having only a reading capability. We cannot update that. That is, the binary cells in the ROM occupy less space in the RAM. That's why for the same size chip, it is possible that it have a more bits of ROM than of a ROM. Now, there is a memory address map. Actually, the memory address map is called as a pictorial representation of assigning the address space to each chip. Each chip here represented as RAM or a ROM. Here is, I am taking an example, that is, suppose there is a computer system needs having 512 bytes of RAM and 512 bytes of ROM. What is the meaning of this? Means the total capacity of RAM chip is 512 cross 8. Here written is over 512 bytes. Means what? That RAM chip capacity is 512 cross 8 and the bytes, 512 bytes of ROM. Means what? The total capacity of ROM is 512 cross 8. Now, the single chip capacity, the single capacity is given as 128 cross 8 for the RAM and the ROM chip has a 512. So, we have to calculate some points and designing the memory address map. How we can calculate? As we know, the computer system memory is used by the RAM and ROM. Here, the total capacity of the RAM is 512 bytes and the total capacity of ROM is 512 bytes. So, the total capacity of the computer system memory is 1024 bytes, or you can say 1024 cross 8. Now, the total capacity of ROM is given and the ROM is given, because we have written over here as 512 bytes, means what? 512 cross 8, and total capacity of RAM means 512 bytes, so 512 cross 8. So, the number of RAM chips according to the formula, the total capacity of RAM upon capacity of the single chip. Total capacity of RAM is what? 512 cross 8 and the single capacity of the RAM is what? 128 cross 8. So, the 4 chips required, and again the ROM chip capacity, because the total capacity is 512 cross 8 and the single chip capacity is 512 cross 8. So, again the 1 chip is required. Now, we can calculate it, the RAM and ROM, number of RAM and ROM chips. Now, the memory connection to the CPU. Memory connection to the CPU is simply defined that how the data or information is transferred from memory to CPU or the CPU to memory. So in this particular example, we can use, because we can calculate it, there are 4 RAM chips are there. 4 RAM chips, and the single RAM chip capacity is 128 cross 8. Next 4 RAM chips, and the one ROM chip is there, and the single ROM capacity is 512 cross 8. We can design all the configurations of a ROM chip, that is, there are CS1, CS2 bar, read, write and address 7. Why address 7? Because the single RAM capacity is what? 128 cross 8, and we can write it over here 2 to the power 7 into 8. So 7 bit of address bus and 8 bit of data bus is required. So here AD7 is there in each RAM. Address 7, AD7, address 7 and address 7 is there. 8 bit data bus is required. This 8 bit data bus, you can see that there is a bidirectional data bus. Bidirectional means from memory to CPU data is transferring, and from CPU to memory it is possible to transferring the data. And in this particular ROM, there is a 512 cross 8. That is means we can write it over here as a 2 to the power 9 into 8. So 2 to the power 9 into 8 means what? There is a 9 bit address bus, and there is a unidirectional data bus, means this particular data or information is transferring to the CPU, but vice versa is not applicable, means CPU to ROM is not transferring any data. Now, in the next, there you can see there is a read and write lines are there. Read and write lines in the RAM. So in the read and write line is there, when the read line is there and the write line is there. In the write line, because we can update whatever data or information is stored in the RAM, so the write lines is there, and the next write and line. And this particular write line will be goes to the all 4 RAMs. Next is the read line. This particular read line again goes to these particular 4 RAM chip and also goes to the ROM with a wire of the CS1, that is chip select 1. Here you can see there, this is the particular line for the CS1. So we can say that the read line, because the ROM having a capacity of the read but not update any particular data or information. And here there is a data bus is directly connected to the all RAM particular data bus and the ROM data bus. Now, in this particular, because there is all the RAMs having what? Address 7 bit. 7 bit address bus is required. So in the CPU, there are 1 to 16 bit address buses there. Starting of first to 7 bit is goes to the all RAMs. That is, this particular RAM 1 to 7 address 7 is going, this particular address 7, this address 7 and this. Because the address line 9 means what? 2 to the power 9, 9 bit address bus is used by the ROM. 1 to 7 goes here, and the next 8th and 9th line of the CPU address bus is goes directly to the address 9 of the ROM. Now, because there are 4 RAMs are there, so we need whatever data or information is stored, where we need a device which can, these 2 bit is converted into the 4 bit. So that's why we are using the decoder, and the size of the decoder is depends upon the number of RAM chips, because there is a 4 RAM chips. So that's why we are using 2 cross 4 decoder. Suppose that there are 8 RAM chips are required in that particular example. Then the decoder size will be changed. Then there will be a 3 cross 8 decoder will be there. So here, because the RAM chips are there, so there is a 1, 2, 3, 4 is there. So decoder is there. And now these decoder, the 2 bits of the CPU address bus, that is 8th and 9th bit. These 8th and 9th bit is converted into the 4th line by using the decoder. That is what? 0, 1, 2 and 3. The 0th bit is goes to the CS1, that is chip select 1. Next, chip select 1 is goes to the RAM 2 and 3 and 4 and so on. So it means what? When the 8th and 9th bit is because the 2 bits are there, so the combination are what? 2 to the power 2, that is 4 combinations will be there. It means when 0, 0 is there, 8th 9 bit is 0, 0, then the data will be stored in RAM 1. When the 8th 9 bit is 0, 1, then the data will be stored in the RAM 2, and when the 8th 9th bit is 1, 0, then goes to the RAM 3, and 1, 1, then it goes to the RAM 4. This is the configuration that how the data is stored in these particular RAMs. And next is the 10th bit. 10th bit select that your data will be stored in the RAM or ROM. 8th 9th bit is selected what? 8th 9th bit is selected that in which particular RAM your data will be stored. But the 10th bit says that your data is going to the RAM or a ROM. In which particular data you are going to store, RAM or a ROM, this will be selected by the 10th bit. Means if the 10th bit is 0, then the data will be goes to the RAM, and if the 10th bit is 1, then the data will be stored in the ROM. So the 10th bit will be decided of the CPU address bus, 10th bit will be decided that your data or information will be stored in the RAM or ROM. Here is the summary of that particular memory connection to the CPU. That 10th bit, if 0 or 1, the data will be stored in the RAM, and if the 1, then the data will be stored in ROM. Now the 8th bit and 10th and 9th bit, that is the 2 will, means combinations of 2, 2 to the power 2. So there are 4 combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. So the data will be stored, if the 0, 0, then RAM 1, if the 1, 1, then the RAM 4 will be stored. Now the next is memory address map. In the memory address map, this is the actually the pictorial representation of the assigned address space. Means whatever the chip address is, we know that the capacity of the RAM is 128 cross 8, but actually the what are the range of addresses can be defined in the terms of the memory address map. When we are going to create the memory address map, there are some components. In this particular example, we have 4 RAMs. That's why we have written over here RAM 1, 2, 3, 4, and the 1 ROM is there. And in the particular example, it is given as an interface register, so that there is a component as an interface register also. After that, because the CPU having the 16-bit address bus, that's why here written over here 1 to 16 is there. Now, because the RAM size is what? 128 cross 8, and 128 cross 8 means what? 2 to the power 7, means 7-bit address bus and 8-bit data bus. Here we are calculating the address range. So, we are using the address bus bits. Address bus bits are what? 1 to 7 is there. So, 7-bit address bus is there. So, all the 7-bit is consider as an in the RAM 1 to 4, we are calculating as a don't care condition. This star is notation as a don't care conditions are there. Don't care condition means either it is 0 or 1, whatever the value, it doesn't depends upon the whatever the address is going on. Now, the 1 to 7 bit why we are taking? Because the RAM size is 2 to the power 7. And the ROM is what? ROM size is 512 cross 8. That's why we are using the 9-bit address bus is there. So, there is a 9-bit address bus and the interface register is already given. So, there is also a 9-bit values are given. Now, as we discussed earlier that the 8th and 9th bit decide your data or information will be stored in which particular RAM. So, the 8th and 9th bit, when the 00, then the RAM 1 is there, then RAM 2, then 01 is there. If the RAM 3, so your data, if the 8th and 9th bit is 11, so your data or information will be stored in the RAM 4. So, that's why it is written over here, that is the combinations of 00, 01, 10 and 11. And the next is the 10th bit. This particular 10th bit selected that your data or information is stored in the RAM or ROM. 8th and 9th bit tells that your data or information is stored in which particular RAM. But the 10th bit says that your data will be stored in the RAM or a ROM. whatever the RAM is possible, RAM 1, 2, 3, this will signify by the 8th and 9th bit. But the 10th bit says that your data will be stored in the RAM or a ROM. So there is a 000, 10th bit means if the 0, then the RAM will be selected, and if the 1, 10th bit is 1, so the data will be stored in the ROM. Now, the remaining bits is considered as 000. So, all particular table we will fill with the 000. And here is the interface register. The 11th bit, if the 11th bit is 1, so the data will be stored in the interface register, not in the RAM or ROM. 11th bit decide that particular data is going to the register, not in the RAM or ROM. So, RAM and ROM, here is a 000 is there, and the interface register is a 1. Now, how we are going to calculate the hexadecimal address? In the hexadecimal address, there is a, because the 16-bit values are there, 16-bit address buses are there. So, 1 to 16 is there. Now, in the first component, that is our RAM 1. RAM 1 is having what? There is a 7-bit address bus, that is of the don't care condition. Don't care condition means what? Maybe 0 or a maybe 1. In the first case, when we are considering the range of addresses as a 0 and a 1, then the value is what? In the don't care condition, all the values put it as a 000. And when the higher order range we find, then all the don't care condition we can write it as a 1. So now for the hexadecimal address, because we are going to take the hexadecimal address, so there is a, we can grouping it out as a 16-bit address bus as a 4-4-bit. So 1, 2, 3, 4 is a one group, next 5 to 8, next 9 to 12, and next is a 13 to 16, there is a grouping. And now this particular 13, 14, 15, 16 bit is 00. So we can write it as 0. Then next 9 to 12th bit is 000. So the second 0 can come over here. This. Next is the 5, 6, 7, 8. Here is the don't care condition. So the 5, 6, 7 bit is what? 000. So the third 0 comes over here. Next the 1, 2, 3, 4 is there. These zeros are there. So the next 0 is come over here. Now, the next is when the higher order range we find. In the don't care condition, these 7-bit value can be considered as 111. In the lower order range, when we are finding out the address, then 000, then the 111 is there, that is the higher order range. Why this 111 we can use at this 0. These zeros are like 0, and next is the 0, and the next is the 111, that is 7, and the last 4 bit as a 1. So we can treat it as a 15, that is F in the hexadecimal address, so that the hexadecimal addresses higher order range will be 007F. By this particular phenomena, we can calculate all the components address of the RAM 2, 3, 4 and the ROM. So we can conclude that the memory address map is defined that all the range of addresses. And this is the combination that 1 to 10 bit we can also use, that 8th, 9th bit is which particular RAM will be stored and which particular RAM or ROM will be selected. This is a simple example I have given, that if the 16-bit address is given, so finding out that which particular, where your data is going to store. So first we have to find out the 8th and 9th bit. 8th and 9th bit is what? 1 and 0. So means 10 means what? Second RAM will be selected for the data storage. The memory access methods, these are the 3 access methods are there, that is random access, sequential access and direct access method. Randomly we can access, sequentially means one by one we can access the data or information, and the direct access, directly we can use, that is a magnetic disk or a magnetic tape, we can directly access or stored in that particular data. Thank you.